Next up, we have Kent Bress, who is the Director of Aeronautics and Cross-Agency Support Division Office of International and Interagency Relations. They always have wonderful long titles at NASA. Please welcome Kent Bress. I think he's there because I heard a chuckle.
All right, I'm here, so thank you very much. And if we could just go to the first slide, please, I'd appreciate it. Thank you. So not to put you through that again, but hi, I'm Kent Bress. I'm the Director of the Aeronautics and Cross-Agency Support Division of the International and Interagency Relations Division at NASA headquarters. So my division is responsible for helping oversee our cooperation with Europe and Canada, and also for support for our aeronautics and space technology mission directorates in their international engagements. I am delighted to be here to say a few words about space exploration under the Artemis Program and our plans for utilizing space resources that exploration will make available to us. Now, I should note right off the bat that you'll have the good fortune soon of hearing a presentation from Jerry Sanders, who is an actual expert on the topic and the lead for our in situ resource utilization in the Space Technology Mission Directorate, or STMD. But I'd like to kick things off by taking just a few minutes to talk about the Artemis Program, the Artemis Courts, how exploration is driven by science, and how science shows the way toward potential economic opportunity. I'll touch a bit on questions like why we explore, how we'll get to our destinations using the transportation systems developed by our Human Exploration and Operations Mission Directorate, and what we'll do when we get there. I'll mention the steps we're taking to provide access to the moon through our commercial lunar services, lunar payload services, or CLIPS program, which is managed by our Science Mission Directorate. And as a small preview of the kind of things Jerry will refer to in his remarks later on, give a brief introduction to STMD's Lunar Surface Innovation Initiative and Lunar Surface Innovation Consortium. So next slide, please. So as you've heard before, the goal of the Artemis program is to return to the moon in a way that truly reflects the diversity of our nation, with a sustainable program of exploration that will enable the eventual goal of placing humans on Mars. So as is typical of lofty goals, this one unites us with international and commercial partners, and even as an agency, bringing together our human spaceflight and operations, science, space technology, and even aeronautics mission directorates together. So NASA has led human space exploration in low Earth orbit with commercial and international partners. The International Space Station missions are a catalyst for economic development and the advancement of scientific knowledge and new technologies that can improve our lives. And the Artemis program will expand human presence in space and bring back new knowledge and opportunities. It will also continue to demonstrate, as the ISS has done, how we can achieve great things when nations work together. And in an era presented with global challenges such as pandemic and climate change, such demonstrations are needed now more than ever. So next slide, please. So we know that working together safely in space requires shared guidelines and practices. And to respond to this need, the US developed the Artemis Courts. In October 2020, we successfully launched and signed the Artemis Accords with 7 countries, and others around the world have signed or are actively looking to do so. The accords, which were negotiated by the original signatories, provide non-legally binding implementation guidance for the Outer Space Treaty of 1967, reinforce the obligations under the Registration Convention and the Agreement on the Return of Astronauts, and establish norms of behavior such as the full, free, open, and timely release of scientific information. The principles include peaceful exploration, transparency, interoperability, emergency assistance, registration of space objects, release of scientific data, preserving heritage, orbital debris, and deconfliction of activities. And on the topic of today, space resources, the Accords note that extracting and utilizing space resources is key to safe and sustainable exploration. The signatories have affirmed that such activities should be conducted in compliance with the Outer Space Treaty. So next slide, please. Could we move the slides forward one, please? Actually, one back. Perfect. Thank you so much. Oops. There we are. So as to the question of why we explore, one of the many answers is that our efforts in doing so have a positive economic impact. The recent report by the University of Illinois shows that through all of NASA's programs, the agency's generated more than $64 billion total economic output during FY 2019. It supported more than 320,000 jobs nationwide and generated about $7 billion in taxes. Now, that study found that our Moon to Mars program generated more than $14 billion in total economic output and supported more than 69,000 jobs nationwide in fiscal year 2019. In other words, it provided about 22% of NASA's economic input. The next slide, please. Oops. Should have numbered them, I'm sorry. It's a picture of the moon, if you don't mind. That's the one. So thank you so much. So to further look at the question of why we explore, there's the contribution that the Artemis program will make to scientific understanding of the universe. Now, with this new knowledge, we also expect to learn about opportunities for economic and social progress based on the ability to utilize the space resources we're discovering. Now, on these next two slides, I'm going to talk about scientific discoveries on the moon. And while I'm no scientist myself, one of the foremost delights of working in the space enterprise is the access I have to the most ingenious people in the world. And I'm grateful for the insights they gave me. And of course, any errors due to poor understanding are mine. So the Apollo missions brought back 382 kilograms of lunar rocks, core samples, pebbles, sand, and dust from the lunar surface. The 6 space flights returned 2,200 separate samples from 6 different exploration sites on the moon, from which we learned a number of important things, such as the moon is very old, about 4.6 billion years. It moves away from the Earth at about 1.5 inches a year. Now, the early moon had a molten magma ocean that cooled to form the crust. Isotopic analysis has told us that the moon and the Earth are virtually identical, a fact that favors the impact theory of formation. And impact cratering is an important geological process, and the moon's bombardment of history is preserved on its surface. And finally, that massive volcanic activity occurred between about 4.2 and 3.16 billion years ago. But while those discoveries were fundamental to our understanding of the moon, they didn't stop with Apollo. Subsequent missions by the US and others like India have extended our knowledge to new regions of the moon. The 6 Apollo missions only collected material from the middle latitudes, but the poles tell an interesting story about the moon's history and present composition. The discovery of water on the moon holds promise for both science and human exploration. We found water inside those lunar samples, but also in the permanently shadowed craters near the lunar poles. Understanding the sources and concentrations of this water will help us understand how the moon formed and evolved and might provide resources for future explorers. We're targeting the lunar South Pole because we believe it's rich in ice, which can be converted to drinkable water, rocket fuel, or oxygen, and other resources that we'll ultimately need to further our exploration in the solar system. And in terms of what we do once we get to the moon, I'm told scientists are eager to start digging, or more accurately, drilling core samples that will actually reveal the nature and distribution of these critical resources. So if you could hit the next slide, please. So in addition to water, the moon's violent history may have endowed it with mineral gifts. The South Pole Aitken Basin is a gigantic structure on the far side of the moon, possibly formed by the impact of a planetoid-sized body 4 billion years ago. Now, looking at data from GRAIL and LRO, we think it's possible that a dense collection of iron-rich materials left over from the impact exists under the surface of the basin. And moreover, ejecta from the impact may exist at the near surface in the northern rim of the basin, which could contain high concentrations of platinum group metals. And as I'm sure this assembly does not need to be reminded, the platinum metals have many useful catalytic properties that make them highly sought after on Earth. They're also resistant to wear and tarnish, making platinum in particular well suited for fine jewelry. And other distinctive properties include resistance to chemical attack, excellent high temperature characteristics, and stable electrical properties. Well, we're currently able to mine the platinum group metals on Earth, including from ancient meteorite impact sites. Our need for them is growing while the supply on Earth is not. And as we explore the solar system, it's natural to consider whether to turn their necks for materials needed by advanced technological societies. So, however, if mining on the moon is ever to be practical, we'll need to think about how to make access more routine and sustainable, which is why I'll turn next to how we plan to get to the moon for the Artemis program. So if you could hit the next slide, please. On this slide, you'll see the major lunar transportation elements of the Artemis program, not including, of course, the newsmaker from Friday, which was the selection of SpaceX to provide the human landing system. At this point, I should say that NASA enjoys administration and bipartisan congressional support for the goals of the Artemis program, and that we fully intend to maintain the continuity of purpose and direction of the program, and we are really excited about the next steps. And since I represent NASA's international office, please indulge me for one moment to let me thank our international partners in the Artemis mission and to restate our commitment to them. We're especially grateful for the contributions that have been made by our international partners to the Gateway, which will enable robust operations on the lunar surface while demonstrating key technologies necessary for a future human mission to Mars. So next slide, please. Thank you. So while NASA's Science Mission Directorate creates new activities and opportunities, I'm sorry, I should go back. Let me turn here. Sorry, to address the steps that NASA is taking to enable access to the lunar surface. So led by NASA's Science Mission Directorate, we're working with several American companies to deliver science and technology to the lunar surface through the Commercial Lunar Payload Services, or CLPS program. These companies, varying sizes, will bid on delivering payloads for NASA, including payload integration and operations, launching from the Earth, and landing on the surface of the moon. Under the Artemis program, commercial deliveries beginning this year will perform science experiments, test technologies, and demonstrate capabilities to help us explore the moon and prepare for human missions. So, and while NASA is a customer for CLPS services, the companies that we work with will be able to offer their services more broadly. So now next slide, please. Thank you. So while NASA's Science Mission Directorate creates new discoveries and opportunities through the CLPS program, and our Human Exploration Mission Directorate creates the systems that will allow humanity to explore the solar system, our Space Technology Mission Directorate, or STMD, is developing the technologies to allow us to go to and return from destinations like the moon and Mars, to land there and return safely, to live off the land, and to explore. In each of these thrust areas, especially to go and to live, they'll require that we manufacture materials and products with local resources to extract oxygen from the soil, collect water from the surface, and produce spacecraft propellant. And while we're talking about the moon, I would note that our robotic missions in orbit and on the surface of Mars have revealed valuable data about the locations and abundance of resources on that planet. So next slide, please. Thank you. So I would like to conclude my remarks with a brief introduction to the Lunar Surface Innovation Initiative, or LSII, which is STMD's technology development portfolio to enable human and robotic exploration on the moon and the future operations on Mars. These activities will be implemented through a combination of unique NASA work and public-private partnerships, such as the Lunar Surface Innovation Consortium described on the next slide. Managed under STMD's game-changing development program, the LSII is meant to target capabilities such as utilizing the moon's resources, establishing sustainable surface power, building machinery and electronics that will work in extreme environments like the super chilly, permanently shadowed craters, mitigating lunar dust, carrying out lunar surface excavation, manufacturing, and construction, and also extreme access, which includes navigating and exploring the surface and the subsurface. Among other activities, the LSSI is conducting 3 workshops this year, including an ISRU supply-demand workshop they held back in October that had over 200 participants, a dust mitigation workshop in February with over 350, and I'm told coming up on May 2nd, a lunar mapping for precision landing workshop that I understand has already had 400 participants sign up. So if you could go to the next slide, please. So the Lunar Surface Innovation Consortium is an element of NASA's LSII, and it teams experts from academia, industry, and government to shape the technologies and systems needed to explore space and the moon in new ways. So it's administered by the Johns Hopkins Applied Physics Laboratory. It operates in collaboration with STMD to foster communications and collaborations in key capability areas. Its goal really is to facilitate communication regarding lunar surface technology capabilities and gaps, and to ensure that the results or findings are passed on to NASA and the entire exploration community. The Lsii focus groups hold monthly meetings to make recommendations for the cohesive executable strategy for the development and deployment of the technologies required for successful lunar surface exploration. And as I mentioned at the beginning, Jerry Sanders, who is an actual NASA expert, will likely tell you much more about our technical plans involving resource utilization. So next slide, please. So as my final slide, let me just leave you with this picture of promise. Like many in my cohort at NASA, I was inspired as a child by the Apollo missions and grew up hoping to live in a future society filled with hope and adventure as depicted in TV shows like Star Trek. And like many of them, I'm still filled with that hope and all the more blessed to have enjoyed a career among so many brilliant and inspiring people. And so speaking of whom, let me return the floor to all of you with my thanks for your indulgence. Thank you.
Thank you so much, Kent, and I'm quite sure a lot of people will want to see your slides in depth as well. I haven't seen any questions written into Kent online, but does anybody in the room have a question for Kent? Yes, one question here.
How about international participation in the programs he talked about?
Okay, you probably didn't hear that, Kent. And your name is? Jos. Oh, yes, Jos. Hello. I can't recognize people with masks on. We have a question about international. You can come say it out loud again.
Yeah, international participation, especially in the last consortium you mentioned.
International participation, especially in the last consortium. Johns Hopkins.
Great.
Meeting.
So thank you very much for that question. I really will defer that to Jerry since he's the expert on things involving the LSII and LSIC. I was presenting that mostly as an example of the kind of public-private partnerships that we're investigating through things like the LSII.
Does that answer your question? Any more questions in the room? Because I'm not online right now. If you want to send a question online, you need to reach me before I stand up. Anyway, thank you very much, Kent. We're running over time, so I'm sure the organizational team will want me to crack on a pace. But feel free to chat amongst yourselves and to reach out to all of our expert speakers online through the chat or through LinkedIn or various other methods of getting in touch with them.